Hi everyone, this is Annay Gowda AB, Assistant Professor from Department of ECE, SPCE Bengaluru. And in this video, I'll be explaining about what's the role of digital signal processing in a student's career and what is meant by digital signal processing, why we should study digital signal processing, and what are the real-time applications of digital signal processing. So first, we'll understand three questions. That is, what is digital signal processing and why we should study digital signal processing and what are the real-time applications or where DSP can be implemented in real time. So before getting into this, first we should understand what is meant by a signal. So signal is anything which carries information, or signal is a function of one or more independent variables that carries information on the nature of physical phenomenon. So if I'm speaking, my speech is also one signal. Okay, so that is conveying some information to you people. So speech can be regarded as the best example for a signal. So if you are seeing the image of a particular person or particular building or particular place, then that image is carrying the information regarding to that person, place, or a building. So image can also be regarded as a signal. So if I say my speech is a signal, then so the amplitude of my voice is varying with respect to time. So time can be regarded as an independent variable and amplitude is varying with respect to time. So amplitude is continuously varies with respect to time in case of speech signal. We'll move on. First, we'll understand what is the basic classification of signals. That is a continuous time signal and a discrete time signal. Okay. So what is meant by a continuous time signal? Continuous time signal is a signal where amplitude is defined for each and every instant of time. Okay. One typical example I have shown here, that is a analog speedometer, where the speed varies between 0 to 120. So here speed can be defined for each and every instant between 0 to 120. That is, it may be an integer value, it may be a decimal value, or it may be a rational value, or it may be a irrational value. So speed can be defined for each and every instant between 0 to 120. So counterpart of this continuous time signal, discrete time signal. So a discrete time signal is a signal whose amplitude is defined only at the discrete instants of time. Okay, discrete instants of time in the sense it is defined only for the integer values of time. Okay, so the example, typical example it is shown here, that is digital speedometer. So if the speed is varying between 0 to 120, so speed is defined only for the integer instants here. So that is, so 0, 1, 2, 3, 4, 5, 6 up to 120. It cannot take any decimal value, irrational value, or rational value. Okay, it can only take the integer instance. Okay, so we'll understand clearly what is the difference between a discrete time and continuous time signal. So in this particular example, the voltage is varying continuously with respect to time. Okay, the time is expressed in terms of milliseconds. So here, voltage is perfectly defined for each and every instance between 0 to 10. Okay, so here voltage I can define for 0, I can define for 0.1, I can define for 0.01, I can define for 0.02. So each and every value, irrespective of whether it is an integer, decimal, a rational, irrational number. So that is a voltage can be defined for each and every value between 0 to 10. Okay, that is a continuous time signal. So discrete time signal, you can clearly see voltage is defined only at the discrete instants or only at the integer values of time. Okay, so if the time axis is defined between 0 to 10, then I can define voltage perfectly at the integer values of time, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I want to define the voltage between the in between the discrete instants or in between the integer values, then the voltage is undefined. Let's take for example, if I want to define voltage at 0.5 here, it is undefined. 1.1 undefined. 2.2 undefined. So it is only defined at the discrete instance of the time. Okay. So this is about the signal, what is meant by a signal, and what is the basic classification. That is, see, in order we are dealing with what is meant by digital signal processing. We have I have explained about a signal, and I have explained about the basic difference between the continuous time and discrete time. So next we'll understand what is meant by a processing. So processing means every signal has some information hidden in it. Okay. If we are analyzing the information hidden in it, or if we are manipulating the information hidden in that signal, or if we are extracting the information hidden in the signal, then we call that as a processing. Okay. So the one typical example it is shown here. Let's take, for example, one signal. If it is contaminated with the noise, okay, then if that contaminated signal, if it is passed through the signal processing, then so that contaminated signal, if it is passed through a filter, so filter, we know it allows only the desirable part of the signal and it blocks all the undesirable part. Okay. So we'll get only the desired signal as the output. So if I am taking filtering as a signal processing technique, then what does filtering does? So filtering allows only the desirable signals and it blocks all undesirable signals. That means, so we are taking a signal, we are extracting that information hidden in the signal, and we are manipulating that information hidden in the signal. That is called as a signal processing. Okay. So we have understood what is meant by signal processing and digital. Okay. So now we'll understand what is the basic block diagram of a digital signal processing. So what is the basic block diagram? In this example, typically I have shown it is having ADC, DSP processor and the DAC. Why this conversion is required from analog to digital and from digital to analog? Okay, because there are two problems here. The thing here is, as a human beings, we cannot understand the machine language, that is zeros and ones. Okay. Similarly, the digital signal processor, it cannot understand the real-time signals, okay, or analog signals. Okay. So all real-time signals are analog signals. If I am talking, my speech is a analog signal. Okay, it's a real-time signal. It's an analog signal. Okay, I cannot process directly my speech signal. Okay, so only if it wants to be understood by this digital signal processor, we need to convert that analog signal to digital. Okay, then the signal is processed by the digital signal processor. Then again, if you want to understand that processed signal, it should be converted back from the digital to analog. Okay, the same thing it is given in the below diagram here it is. So if the person is speaking through the microphone, then if we want to process the speech of that person, then definitely the speech signal, that analog signal, it has to be converted into digital, and then digital system process that signal. Okay, and again the digital signal has to be converted into analog if you want to play through a speaker. Okay, so this is what the scenario of a digital signal processing. So next, so why we should study digital signal processing? Because digital signal processing is the fundamental subject for many subjects, okay, which is listed here, starting from communication theory, analog communication, digital communication, image processing, speech processing, analog signal processing, modern digital signal processing, numerical analysis, probability and statistics, digital electronics, analog electronics. So if you want to understand the communication theory subjects or other subjects, so we should have the thorough knowledge of digital signal processing. As I discussed, so this DSP, it is the fundamental for many of the subjects. Okay, so starting from analog communication, digital communication, image processing, video processing, speech processing, and the DSP architecture. So if you are choosing your career in the digital signal processing field, then definitely you are having n number of opportunities. So there are many companies, the good companies who are looking for the engineers who are having the thorough knowledge on the digital signal processing concepts. Okay, so few of companies which have been listed in this particular slide. So now we have discussed about digital signal processing and what is the role of digital signal processing, and let's see where digital signal processing can be applied in real time. See, knowingly or unknowingly, we are using digital signal processing everywhere. Okay, but it is difficult to list all the applications. So I have listed few applications here. Okay, so we'll discuss that. First thing is radar and sonar. So radar and sonar, it is mainly used in the defense purpose in order to detect the unknown objects, or in order to detect the in order to detect and trace the enemies, okay, who are entering our area. So in radar and sonar, DSP is mainly used for the target detection. Okay, so as we have seen in this particular example, okay, so in order to detect the target, okay, and in order to detect the position of the target and the velocity with which it is traveling, okay, so we can use this digital signal processing techniques. Okay, similarly for tracking, so if any unknown object, if it is entering our border, then definitely through the digital signal processing techniques, so we can send an emitted wave. If that wave hit the target and the reflected wave, after analyzing this reflected wave, we can estimate the parameters, or we can estimate the properties related to that target. Okay, what is the distance of the target from the border? Okay, so or what is the velocity with which the target is moving, in which direction it is moving. So all those parameters can be extracted using the digital signal processing techniques, because as I said, see, all these are all signals. If the signal is having some information, so through the processing techniques, we can extract, we can manipulate, okay, or we can analyze the information hidden in that signals. And next example, next application is a biomedical field. So we know that DSP is an integral part of the modern day biomedical field. Okay, because without signal processing techniques, it is difficult to imagine the biomedical field. Okay, so starting with ECG signal, which carries information related to the human heart. Okay, so EEG signal, which carries information related to the human brain. So all these medical signals are having some information, not only ECG, EEG, you can take EMG, you can take mammogram, you can take MRI. So all these are carrying information related to that patient. Okay. So when we are extracting the information hidden in these signals, and when we are manipulating that information hidden in those signals, then definitely it is very helpful, because it is pertaining to the life saving question of that particular person. Okay. And as I said, it is difficult to list the applications of the DSP in one or two slides. Okay, DSP is used everywhere. So knowingly or unknowingly, we are using the digital signal processing in our day-to-day life. Okay, starting from the digital television, digital camera, internet, okay, and mobile phone, that is cellular communication. So everywhere the role of digital signal processing is there. Okay, so only it is very important for us to understand the basic concepts of digital signal processing, and we should have the thorough knowledge of digital signal processing, because it forms the fundamental for many of the subjects. Okay, so in my future videos, I'll be explaining about the discrete Fourier transforms, okay, and its properties. Thank you.